In this video, I will go over the homework that follows lecture 12.2, and this has the potential of becoming one of your most favorite homeworks, because in this homework, this is when you are officially allowed to use technology to do calculus. So if you're not familiar with how to use technology, please watch this lecture, and let's go ahead and jump right into it. So in first question, I'm asked to integrate, and in this case, this is probably we don't even need this whiteboard here, right? So let's just open Wolfram Alpha and let's just type the problem right into the Wolfram Alpha. So we do an integral. You can type the integral. Make sure you follow the syntax correctly. Here we have 30 divided by x, 2 plus x cubed. We have another parenthesis. And press enter. Now, make sure your input was interpreted correctly. So it seems like it was. And now we're just going to type the answer. Now, in Wolfram Alpha, it uses logs as natural logs. And also it doesn't like using absolute value. So let's just stick the absolute value in here. See if they're going to make any damage. But I think in this particular problem, they do belong there. You may be marked correct even if you don't use them, but technically they do belong there. Again, technology is just technology. It doesn't always produce the answer that makes 100% sense. All right. Just keep them coming, right? Here we have 72 sine to the power 6 of 7x. Again, when entering the powers for trig functions, make sure they are interpreted correctly. In this case, I'm not sure, so let me just throw an extra parenthesis around this and then raise it to the power 6. And if the answer is the same, then it means it doesn't matter. It seems like the answer is the same, so we're just going to type it up here. We got 72. Oh no, did it change? Looks like it changed. Huh, I'm not sure if it changed anymore. Might have to rewind and take a look at it, but I'm just copying it over. And remember that you can still make mistakes by copying it incorrectly. So the fact that you're allowed to use technology just means the stakes are now higher. That means you are not allowed a mistake. There's no excuse for you to get the answer wrong. Here we're looking for the area, so this is a definite integral. This problem may require a little bit of setup, so let me open my whiteboard. And problem 2 was done. This is problem number 3. So if we're looking for the area, it's the integral so here's your function, here's your a and b, and this is what this integral does. So in our case, we have to set up an integral from 0 to pi of tan sine to the power 4x dx. So that's what we are computing. Now, if you're looking for definite integral, so for definite integrals, we have few options, right? We can go back to Wolfram Alpha. It's still a great option, right? So let me just adjust this one. So we have tan sine of x raised to the power 4. That will give me just the general antiderivative. So if you want to make it a definite integral, you can just type integral, and you can say from 0 to pi. And I think it will understand it. It should understand it, right? Now, the other option is Desmos. And if you use Desmos, in Desmos you can also type this integral, just same way. And I don't think it likes power forward here. In Desmos will give you the answer, but you wouldn't know the exact answer. It gives you the approximation. So you might have to play with it and try to guess what that answer is. So it looks like the answer is 4 pi over 15s, right? So again, this is like a little trick to... Oh no, hold on. So 15 fourths... Oh yeah, I flipped it. 15 pi over 4 is the answer, which is what we got here. Either way is what we're going to type here. 15 pi over 4. So you can definitely check and double check your result before you put it in as your answer. Now, if it's not asking you for the exact answer, I actually missed it. I don't know if it asked for the exact answer. Then you can just use Desmos. So number 4, we ask to find the area between the graphs. So the area between the graphs is the integral of the difference of the two functions. The one that is greater goes on top. The one that is below goes on the bottom. So this is your f, this is your g, this is your a, this is your b, and this integral computes this area. So that means in our problem we are asked to find the integral from 0 to 1 of, and now we may want to graph both of those curves. So I don't know which one is above, which one is below. However, we actually don't have to worry about graphing it, because if the answer is negative, then actually, hold on, the picture is given to us. So clearly the f is above, right? So we don't have to graph it. But this is the integral that we have to set up. And again, we're going to set it up by just typing it here. We have integral from 0 to 1. And here we have 3x, what was it, cubed? Times square root of 3x to the power 2 plus 4 minus parenthesis 1 over 3. Just write it as x over 3 minus 1. Is it asking for the exact answer or no? It says 3 decimal places, which is great. So we can just put 2.667. Now, if you are allowed to use technology on a test, which in this case, very unlikely, but it's still a good habit to just show what technology you used to produce the answer, so you can go back and check your own notes and follow your own solution in case if you have to find a mistake or something like that. So the answer is 2.667. It's giving me the link to Desmos. I have to choose my A to be 2, my B to be 6, and the function here is, I have to type my own function, which is fine. Like, we can do that. And I'm not sure what this is doing. This should be, this meant to show the area, right? But because the graph is below the x-axis, it's not showing it, so we just need to, and if you want to make a use of this link, we just need to swap the x and y. That's the area that we're finding, and it makes sense because it's below the x-axis, it's negative. Similar problem, we'll just use the same one. F of x is 5 tangent 2x to the power 3. I need to make sure that 3 is outside of the tangent. And here we have secant of 2x to the power 5. So that's my function. We're looking for the interval from 0 to pi over 8. Looks like the function from 0 to pi over 8. We may change this back. Right, so okay, there you go. So this is the interval. This is the region, the area of which we're finding. It's clearly positive. So the answer is 1.355. So this is what we are looking for. And to find it, we're going to type the integral from a to b of f of x minus g of x. And I'm going to throw the parentheses. And that's the answer. Above the x-axis means this is 0. Here we're gonna just put 2 cosine squared x. Here we have sine squared x. Here we have coefficient 2. The limits are from pi over 4 to pi, and this is what it looks like. I guess Desmos doesn't like this powers period, so and this is the problem from pi over 4 to pi. And here's the answer, right? So it's just 0.589. And we're done. If you have any questions about how to use technology to find definite and indefinite integrals, feel free to reach out.